All right, so get this. We're diving into AI today.
Ooh, sounds fun.
But not just any AI. We're talking vision language models, VLMs.
VLMs, those are pretty cool.
They are. It's like AI that can see and understand images like we do.
Yeah, I've been reading about some new research on them. Really interesting stuff.
That's what this deep dive is all about, some fascinating new research papers.
Cool, what are they saying?
Well, it's all about a new approach, moving away from the old, complex VLM designs.
Oh, I see where this is going. Something simpler, right?
Exactly, but potentially way more powerful. They're calling it EVEv2.
EVEv2, okay, I'm intrigued.
So think about traditional VLMs. They use separate encoders for vision and language.
Yeah, I know what you mean. It's like needing it translated between two people speaking different languages, right?
Exactly, but with EVEv2, they ditched the separate encoders. It's a single, unified architecture.
Whoa, no more translator needed. That's a pretty big change.
Huge. It's like everyone suddenly understands each other perfectly.
Makes things a lot smoother, I imagine, more efficient.
Way more efficient and adaptable.
So how does it actually work? They're not just throwing everything together in a box and hoping for the best, are they?
No. The paper talks about this divide and conquer approach.
Divide and conquer, huh? Go on.
Basically, EVEv2 splits up tasks within the model, minimizes interference between the vision and language processing.
Smart. So instead of everything getting jumbled together, it's more organized, kind of like different departments in a company.
Yeah, I like that. It's like you have your vision team, your language team.
But they can still talk to each other, work together?
Exactly. The paper calls these modality-aware components. They process things separately, but they can still interact.
Neat. Okay, so EVEv2 understands images and text, all in one place.
Right. But here's the crazy part. Get this. It learns to see from scratch.
From scratch. Like, no pre-trained knowledge about what things look like.
Nothing. It's like a baby opening its eyes for the first time.
Whoa, that's gotta be tough. How does it even start?
They use something called a patch embedding layers. It breaks images down into tiny pieces, kind of like pixels.
So instead of seeing a whole picture, it's like looking at each tiny detail one by one.
You got it. And over time, it learns what these little pieces mean, builds up its own understanding.
Wow, that's pretty amazing. It's like it created its own visual dictionary.
Exactly. And this learning from scratch thing, I think it could be a game changer.
Interesting. How so?
Well, think about it. Maybe it helps EVEv2 be less biased, less reliant on specific data sets.
Oh, I see what you mean. If it's not starting with preconceived notions, it could be more adaptive.
Exactly, like more open-minded. But data is still super important.
Obviously, that's how it learns. How much data are we talking?
100 million pieces of data.
100 million? That's a lot.
It is, but here's the kicker, that's actually less than what other VLMs need.
Huh. So it's learning efficiently, too.
A super learner. Imagine what it could do with even more data.
The possibilities are pretty exciting, right? But data's not everything. It's got to be good data.
Absolutely. They use this engine called Dense Fusion++ to make sure the descriptions were really accurate.
So it's getting good quality information to learn from. Makes sense. And all this leads to good results, I hope.
Incredible results. EVEv2 beats other encoder-free models and rivals traditional VLMs.
So it's proving that simpler can be better.
Right. It's holding its own against the big guys. But we should probably hear about what it can actually do.
Yeah, that's the exciting part. Tell me more.
So EVT is beating the competition. That's impressive. But what can it actually do?
Oh, we're getting to the good stuff now. Remember that patch embedding layer we talked about?
Yeah, breaking down the image into little pieces.
Right. Well, because it learns in this way, EVEv2 isn't just memorizing entire images.
It's actually understanding what makes up those images, like the basic building blocks.
You got it. And that makes it much more adaptable. Traditional VLMs, they struggle with new images.
Images that are different from what they were trained on.
Exactly. Like trying to understand a foreign language with only an English dictionary. Doesn't quite work.
Definitely not. But EV2, it's built for this, learning and adapting all the time.
A visual learner, constantly expanding its vocabulary.
That's a good way to put it. And this adaptability, it's got so much potential.
Imagine AI that can actually see the world like we do.
Like really understand what's going on.
And not just on supercomputers either. EVEv2 is so efficient.
You're thinking we could have it on our phones, in our homes.
Exactly. Healthcare, education, even art and design. The possibilities are endless.
It's mind-blowing. But with all this amazing potential, there's got to be some challenges too.
Of course. It's still early days. Scaling up these models is a big one.
Even though it learned so much from 100 million pieces of data, it needs more.
It does, but it's not just about quantity.
Quality matters too.
Absolutely. Remember, Dense Fusion++ that ensured EVEv2 was getting high-quality descriptions.
So we need to keep feeding it good data, not just any data.
Right, and that brings us to another challenge, the computing power needed.
Training these models takes a lot of resources, right?
A lot. Like building a rocket to go to space. We need more efficient algorithms, better hardware.
So we have to push the boundaries, but also make sure it's sustainable.
It's a balancing act, that's for sure. And then there's the question of how we evaluate these models.
Yeah, it's not just about test scores, it's about real-world
We
performance.
need to see how they handle new situations, ambiguity, even continuous learning.
It's like testing a student's problem-solving skills, not just their memorization.
Exactly. And as we move forward with this technology, we need to think about the societal impact.
AI is powerful. We have to be careful how we use it.
Open discussions are crucial. What are the benefits? What are the risks?
How do we make sure AI benefits everyone?
It's a collaborative effort involving researchers, policymakers, and society as a whole.
We need to ensure responsible and ethical development.
Absolutely. But amidst all the challenges, it's important to remember what an exciting time this is.
This new breed of AI is revolutionary.
The potential of encoder-free VLMs is huge. They could change how we interact with the world.
It's truly inspiring, but we've covered a lot of ground today. Maybe it's time to wrap things up and give our listeners some food for thought. So we're back, and I gotta say, in encoder-free VLMs, this is big stuff.
It is, but big stuff comes with big responsibilities, right?
Exactly. We can't just ignore the potential downsides.
We touched on it before, but one of the big ones are making sure these models are used ethically.
Ethically, yeah, because even though EV2 learns from scratch, it still relies on data we create.
And we all know humans, we have our biases.
Oh, yeah, for sure. So that bias can creep into the data, even unintentionally.
So as we give these models more and more data, we have to be really careful about what we're feeding them.
Like, it can't just be any old data. It has to be balanced, representative.
Right, think of it like a student's education. They need a variety of viewpoints to get a complete picture.
I like that analogy. And thinking bigger, we have to consider the impact of these models on society.
AI is becoming more and more a part of our lives.
It's changing how we work, how we interact with each other,
So we need to have these open discussions about how AI is shaping our world.
about the benefits, the risks, all of it.
It's a choice we have to make. How do we want AI to be used?
It's about creating a future where AI benefits everyone, not just a select few.
Couldn't agree more. And that brings us back to responsible AI development,
Yeah, it's not just about the technology, it's about aligning it with our values.
making sure AI serves us, not the other way around.
Powerful stuff. And as we wrap up this deep dive, I think that's a key message for our listeners.
This tech is incredible, but it's on us to guide it in the right direction,
We need that sense of wonder, but also that sense of responsibility.
to recognize the power but also the limitations.
It's a journey we're all on, and it requires collaboration, honesty, asking tough questions.
I think our deep dive today has given everyone a lot to think about, a foundation for these important conversations.
Absolutely, we've looked at how these models work, what they can do, the challenges, and the ethical side.
And I hope our listeners are walking away feeling informed, even inspired,
Ready to embrace the potential of AI, but also to approach it with a critical eye.
to be part of shaping a future where AI empowers us all.
Couldn't have said it better myself. So that's it for our deep dive into encoder-free VLMs.
Thanks for joining us, everyone.
Keep learning, keep questioning, and keep exploring the amazing world of AI.